Hello, Vihan, can you hear me?
Yes, sir, you're audible.
Okay. Turn on a video. Turn on your
Yes,
video.
sir, just a minute.
Yes, Vihan. Can you hear me?
Yes, sir, you're audible.
Right. So now, Vihan, are you comfortable with that some reaction part?
Yes, sir.
Right. So today we are going to start with a new chapter, that is a carbon and its compounds. Right? Carbon
Okay.
and its compounds. I will be giving you introduction of this chapter. I'm talking about the living world. Maybe plants, maybe animals, maybe some bacteria or virus or fungus, right? Anything that is from the living system. All the living organisms are made up of such molecules, such compounds which are carbon based, means carbon. In all the molecules, all the component of the living system is made up of carbon and its compounds. Clear? Yes, Saru? Can you hear me? Mavish? Mavish,
Yes, sir.
turn on a video.
Sir, I can't. I'll send a mail.
Okay. So Daniel, Vedant, can all of you
Good
hear
evening.
me? Good evening. Turn on a video.
Yes, sir.
Vedant.
Yes, sir. 1 minute.
Right. Vedant, turn on video. It's mandatory. Yes, Vedant. Right. Okay, I'm starting, continuing now topic now. So I'm starting with the carbon and its compound. The topic of the day, the chapter is carbon and its compound. In its introduction, I'm giving you one clear cut concept, that is all the living organisms, maybe plant, maybe animals, maybe some bacteria, fungus, virus, everything is made up of carbon and its compounds, right? Whatever we eat is made up of carbon, right? Whatever we are using in our daily life, like soap, detergent, medicines, petrol, diesel, all these are made up of nothing but the carbon compounds, carbon, hydrogen, oxygen, nitrogen. These elements combine to form such molecules which we call as an organic molecules, which are part of the living organisms or living organisms, right? Or they use these compounds. For example, we cannot eat anything inorganic, which is not organic. We eat only the organic systems. Either we are taking the plants, right, as our food, Or some people take the non-veg also, that take the flesh, that is again animal. Organism, it means all we are made up of organic molecules. All the molecules which are made up of the carbon, hydrogen, oxygen and nitrogen, they are collectively called as organic molecules. Am I clear? Am I clear? Can all of you hear me? Can all of you hear me?
Yes, sir.
Right, Jordan. Right. Keep on responding. So, what type of bond carbon can make? Can carbon make ionic bond? You have done the ionic and covalent bonding in our previous topics. Can carbon make ionic bond? Any idea? Vian.
So we haven't done that.
Yes, Mavish. Tell me. Can carbon make ionic bond? Any possibility? If yes, how? If not, why not? Tell me. Any reason? Yes, Prem Jaram. Sheikh. No
No
idea?
idea, sir.
No idea? Hmm?
No idea, sir.
Okay. Wait.
So they don't form ionic bonds.
They form or not?
They don't.
They don't. Why? Why don't they form ionic bonds?
Because it shares its electrons.
It shares electrons. But question is why it doesn't make ionic bond? Why does it not make ionic bond? See, to make an ionic bond, it must form ion. Okay, what is the ion? Saru, Vihan, what is ion?
Ion is the atom that has a negative or a positive charge.
Okay, so how is like what do you call positively charged particle?
Protons and electrons. Positive is proton and negative is electron.
Okay, so what do you call that particle when it is positively charged? Suppose I say Na positive, sodium positive. What do you call it? What do you call it? When any atom acquire positive charge, what do you call it? Cation? Yes or no? I'm sharing my screen with you. Can you see my screen? Can all of you see my screen? Yes or no? Speak out, please.
Yes, sir.
Right.
Yes, sir.
This ion is of two type. One we call as a cation, other is called as an anion. Any element after losing electron acquire positive charge. We call cation. If any element acquire gains electron, that become negatively charged. We call it the anion. Right. Now question arises here. To make an ion for a carbon compound, can carbon acquire positive charge or carbon can acquire the negative charge? To complete the octet, I had taught you the octet theory last time, yes or no? Have I taught you the octet theory last time in the previous topics? Metal, non-metal and other previous topics? Yes or no? Okay, let us try to understand here. Octet theory. Write down. According to this theory, an atom is stable. Write down. An atom is stable only when it has 8 electrons in its outermost shell. An atom is stable only when it has 8 electrons in its outermost shell. If it is less than 8 or more than 8, it is unstable. If it is less than 8 or more than 8, it is unstable. And to complete this 8 electron outermost shell, it can make two types of bonds. One is called as a covalent bond and second is called as a ionic bond. It can make two types of bonds. One is called as a covalent bond and other is called as an ionic bond. Okay. What is covalent bond? Can you tell me? What is covalent bond? I'm stopping sharing for a minute. All of you have turned off your video, huh? And number two, you're not talking to me. What happened? Keep on interacting with me. Zo Daniel, Prem, Mavish, everyone. Are all of you there? Vedant?
Yes, sir.
Yes,
So what is the covalent bond then?
sir. An atom that shares.
You could speak at that time also. Yes or no, Prem?
Yes, sir.
Yeah. So keep on interacting
Actually,
with me.
my
Don't give me excuse.
yes,
Don't give me excuse.
sir.
Just speak out. Whenever you know the answer,
Okay,
partially wrong, yes, but you speak out. Don't give me excuse. Keep on interacting with me.
okay, okay,
Yeah.
sure.
So covalent bond is formed by the sharing of electrons. Right now, the covalent bond is formed by sharing of electrons. And what is the ionic bond? Vedant. Shake. Prem.
Hello,
Yeah. What is the ionic bond?
sir. Sir, I'll be giving you the answers in the chat. Is that okay?
No, I can't see your chat. When I'm sharing my screen, I can't see your chat. Speak out.
Because sir, I can barely see the screen share. I'm having some network problem.
Okay. Can you see my
I
screen
can
now?
share the screenshots if you want, but
No,
it's
no,
blur for me.
no. Anyways, can you see my screen? Can you see my screen, everyone? I stopped sharing.
So we can.
You're too late to give a response. Too late. By the time I stop sharing, I think that there's some problem with it, right? Keep on interacting with me, right? Okay. I'm sharing my screen now. Now, can you see my screen?
Yes, sir.
Okay. So ionic bond is formed by the transfer of electrons. Ionic bond is formed by transfer of electrons, and covalent bond is formed by sharing of electrons. Right? First of all, I'm discussing about the examples of the covalent bond. Like we have H2. What is the atomic number of hydrogen? Can all of you tell me? Atomic number of hydrogen. Zordaniel. Sheikh.
1,
1. What is the electronic configuration?
1,
1. So how many electrons are present in the outermost shell?
1.
1. So hydrogen with 1 electron. Second hydrogen with 1 electron. They make a bond and the duplet is complete. And this bond is called as a single covalent bond. This is called as a single covalent bond. Right? Single covalent bond between H and H. Now I am making Cl2 molecule. Can anyone if you tell me the atomic number of chlorine? Okay, now I'm giving you atomic number 17. Can you tell me the electronic configuration?
2, 8, 7,
So how many electrons in the outermost shell?
7,
So if I make the electron dot structure, I'll make it like this. There are 7 electrons. Paired and 1 electron is unpaired. Second chlorine atom also has same 7 electrons. And then their unpaired electron make a covalent bond such a way that they complete their octet. And we again say between the two chlorine atom there is a single covalent bond. Between two chlorine atom there is a single covalent bond. Am I clear?
yes,
Right. Now, note it down everyone.
yes, sir.
Right. Let us take an example of ammonia NH3. Nitrogen, atomic number 7. Tell me the electronic configuration.
2, 5,
Okay. So I'll show these 5 electrons like this. 2 paired and 3 unpaired. And hydrogen has only 1 electron in the outermost shell. They'll be sharing electron here, complete that duplet. Sharing and completing that duplet. Right? And here the nitrogen will be completing its octet. Completing octet. Hydrogen is completing its duplet and hydrogen is completing its duplet. So this and the 3 hydrogens are here. These are the electrons. This pair of electron that is present in the outermost shell but they do not take part in bonding. This is called as a lone pair of electrons. And these pair of electrons which are involved in bonding, these are called as a bond pair of electrons. Am I clear? Noted down, everyone?
Yes.
Right. I'm stopping sharing for a minute. Yes, Zordaniel, Prem, Vedant, can all of you understand?
Yes, sir.
Right.
Yes.
Right. If you find any difficulty, just let me know, right? And keep on
Sure,
interacting
sir.
with me. Keep on interacting with me. Right? You can speak out. I'm now again sharing my screen with you. Now, I'm discussing here carbon, methane, CH4. Central atom is carbon. Atomic number carbon? 6. Electronic configuration? Electronic configuration?
4.
Repeat.
2 and 4.
2, 4. So how many electrons are present in the outermost shell of the carbon?
4.
4. These are known as a valency. We call it say valency. Valency means those number of electrons which are present in the outermost shell and they are available for making bond. So there's a valency is equal to 4. And the hydrogen is atomic number 1. It has only 1 electron. So here we have a covalent bond between carbon and hydrogen. The hydrogen is completing its duplet. Hydrogen is completing its duplet and the carbon is completing its octet. You can see carbon is completing its octet. So 4 bonds are formed between carbon and hydrogen. We can say all the 4 bonds are single covalent bonds. Am I clear?
Yes, sir.
No. Let us make for the O2. Oxygen, atomic number 8. Electronic configuration. Electronic configuration.
2, 6.
2 and 6.
Yes.
So this carbon atom, this oxygen atom has now 6 electron in the outermost shell. And now their 2 electrons will be now sharing and completing the octet. So oxygen, double bond oxygen with 2 lone pairs on each oxygen atom. These are called as a lone pair of electrons, and in between these electrons are called as a bond pair of electrons. Understood?
Yes, sir.
Now, let us make it for the nitrogen molecule, N2. Atomic number of nitrogen.
So,
Yes.
so what all did we do?
Pardon?
What all did we cover? till now.
Wait. I have stopped sharing. Yes, who is here?
Vihan,
Rihan.
I was here. Yes, so I had a power cut.
Okay, from here you will understand. No problem. Right?
Okay.
Rihan,
Yeah.
we started with the covalent bond, right?
Okay.
How much? Where did you join?
No, so I got disconnected very early.
Okay. Wait.
I
Everybody,
can just.
yeah. Wait. Everybody, be sure before the class, just before the class, 5 minutes before, ensure that you have power backup with you, good internet connection, right? All your headphones ready, camera is working, everything. Please check before the class, right? Then you join the class comfortably. You will understand a lot. Class will be beneficial for you, right? Otherwise, what will happen? Sometime you're coming and sometime you're going. It's just a joke for you, really. Wasted of time if you are doing like this, if coming and going and coming and going, right? Before the class, 10 minutes before, check everything that you have enough power bank, power backup, your battery is full. Even if the power goes, you have a power backup with you, good internet connection, camera on, audio on, clear? Everything should be checked before you start the class. Then this class will be useful for you. Otherwise, it is just a sheer wastage of your time and money, nothing else. Clear? Okay, now I'm continuing the class. So Vihan, again, Vihan has gone. Vihan is here. You're here. Okay. So Vihan, if you can start your video, that will be okay. Everybody, please. If you can start your video, that will be good. If you really can't, that is the excuse. Okay, no problem. But if you really want to learn from my class, sit in the front bench. Means video on. Right? Otherwise, I don't know whether you are roaming somewhere and attending the class. Right? Some of my students roam in the market and they are attending the class. Really, it happened with me. Many students have joined like that. They are roaming in the market and attending the class. And suddenly they turned on the video, also turned on the audio, and they were asking some shopkeeper, please give me this burger, please. And I heard that they are in the market and buying burger. So sit in the front class, right? Okay, now I'm starting with it. We had done simply a bonding here. You understand from here. I'm now sharing my screen. Student, please keep in mind that when I start sharing my screen, I can't see your chat. I can't see your faces. So whenever we want to ask anything, please turn on the video, audio, and ask me. Okay, now this is nitrogen, atomic number.
7,
7. Electronic configuration,
2, 5,
2, 5. What is the valency? Valence electrons, 5. Right? So these are the 2 pair of electrons and 3 here. Second nitrogen atom has also this. And now they can share their electrons and complete their octet. And complete their octet. So triple covalent bond is formed. We say triple covalent bond is formed. Triple covalent bond is formed. Am I clear?
Yes, sir.
Right. Now, in this molecule, two similar atoms are combining. So we call this is a homoatomic. Homoatomic means the two similar atoms are combining, and diatomic molecule. Homoatomic, diatomic molecule. Homoatomic means two similar atoms are combining, and diatomic means two atoms are combining. Oxygen is also homoatomic, diatomic. Yes or no? It is also homoatomic, diatomic. Am I clear? I'm waiting for response. Understood the meaning of the word homoatomic, diatomic?
So what's diatomic?
Di means two atoms are combining, and homoatomic means similar atoms are combining. Means both the
So there is not single covalent bond.
if I have a single bond, oh, you have joined late, I think so. Whose
No,
question?
no, no. So I didn't note it down properly. I wanted to note it down.
Okay,
I was.
okay. See, whenever we have a single bond sharing, I'll start from the beginning here. See, how many bonds are shared between these two atoms? Only one bond? Single covalent bond. Am I clear?
Yes, sir.
So this is also homoatomic, diatomic molecule. Homoatomic, diatomic molecule. In case of the chlorine molecule, again you can find between two chlorine atom there is a single covalent bond. One bond is found only, sharing of one pair only, and so we call it a single covalent bond. This is again homoatomic, diatomic molecule. Homoatomic because two similar elements are combining here. Diatomic means two atoms are combining here. Molecule. Homoatomic, diatomic molecule. Understood?
Yeah.
Now, in case of the ammonia molecule, this molecule is called as ammonia. Between two atoms, again a single bond is formed, but three in number. These are all single covalent bond. But here, different elements are combining. So this is a heteroatomic. Heteroatomic means one is a nitrogen, other is a hydrogen. And it is made up of four atoms in all. So we call heteroatomic, tetraatomic, tetraatomic molecule. Heteroatomic, tetraatomic molecule. Heteroatomic, tetraatomic molecule.
So
Am I clear?
tetratomic means four.
Four. Tetra means four. So total four atoms are there in the molecule. So we call tetraatomic. Why hetero? Because different elements are combining. Right? Come to the methane molecule here. You can see single covalent bond between carbon and hydrogen. And it has a five atoms. When it is more than four atoms, we simply call polyatomic molecule. And it is a heteroatomic because carbon and hydrogen two different elements are combining here. Vihan, are you getting now?
Yes, sir.
In case of oxygen molecule, I had told you homoatomic, diatomic, and the bond between the two oxygen atoms are 2 in number. So we call it a double covalent bond. Double covalent bond. Double covalent bond. In case of nitrogen, we have a triple covalent bond. Yes, anyone having any doubt?
No, sir.
So what are covalent bonds?
The bond formed by sharing of electrons.
Okay.
The bond formed by sharing of electrons is called as a covalent bond.
Okay, sir. Thank you.
Now, next. Next topic, write down. Allotropic forms of carbon. Allotropic forms of carbon. Write down. The phenomena of existence. Write down. The phenomena of existence of an element in two or more forms which had different physical properties but same chemical properties is called allotropy. And the different forms are called allotropes or allotropic forms. Understood?
Yes, sir.
Now, the carbon has two allotropic forms. Carbon has two allotropic form in general. Number one, I'm going to discuss about the diamond, the pure form of the carbon. Second is the graphite. First of all, I will discuss these two, then I will also discuss the other forms also. Graphite and diamond, both are basically made up of the pure carbon, only carbon. But their structure is different. Their physical properties are different, but chemically both are same. So we call that these are allotropes of carbon. See now, existence of two or more forms having different physical properties but same chemical properties are called allotropes. So carbon has two allotropes, diamond and graphite. Diamond and graphite. First of all, I'm discussing about diamond. Before I go ahead, do you have any question you can ask? You want to ask anything?
So,
No, sir.
does that mean that we have
Prem,
graphic?
Prem, could you please repeat your question?
No, sir. If the diamond and graphite are same, then it means the value of diamond is also the same as value of graphite.
Value. What do you mean by value here? Value means in terms of money.
Ah, yes, sir.
See,
Somewhat.
the the pencil that right now you're using, pencil, its black part is known as is a graphite, and your pencil is not as costly as diamond. Yes or no?
Yes, sir.
Okay. See, the money value of anything is a concept of economics. Otherwise, for the chemistry people, for the scientific people, the coal, graphite, or diamond all are same. Chemically, all are same.
Okay.
Right? For me, all are of equal value. All are just made up of carbon only. But if you ask me that which is more costly, that is a question of the economics. Then why is diamond so costly and why graphite is so cheap? I think that is a question of the of economics. Yes or no?
Yes, sir.
Right. So if I teach you a little bit of economics in the class of chemistry, then I can say that anything that people want and it is present in less quantity, then it is costly. Got it?
Okay. Yes.
People want something and it is present in less quantity, then the seller will make it costly. Right?
Okay.
This is a simple like business. I call it business. Right? It is just like this. I'm giving you one simple example here. Um, air tickets. 2 months before the flight, it is cheap, but on the day of the flight, it is very costly. Have you ever observed this?
Yes, sir.
Right. So when seats are less and
The
it is in
demands increase.
and it is in more demand, it becomes costly. Same thing as the diamond and the graphite also. But for the scientific people like us, diamond, graphite, coal, whatever made up of carbon only, nothing else.
Okay.
Right? All are same for me. Right? Okay. Now I'm now sharing my screen with you. So diamond. In diamond, every carbon atom is bonded with 4 other carbon atoms. Every carbon atom is bonded to 4 other carbon atoms. Continue. And gives a 3-dimensional network. Gives a 3-dimensional network. This is having angle 109 degree 28 minutes. Carbon atoms are arranged in the 3-dimensional space in such a way that they give a giant molecule. This angle is called the tetrahedral angle. and this bond length is 1.54 picometers. 1.54 picometers. All the bond lengths are equal here. So in diamond, carbon atoms are arranged in this form. This is the existence structure of the diamond. Am I clear?
Yes, sir.
Now, next write down physical properties of diamond. Number one, it is hard. High density. Because the atoms are tightly packed up, high density, they have a high melting point. 3930 degrees Celsius to 4203 degrees Celsius. No, it is set, or we can say in the Kelvin scale or in degree scale. They are electrically insulator. Because they don't have any free electrons. They're all the four electrons you can see in the structure, the valence electrons are bonded. There are no more free electrons. So they are electrically insulator. And they are transparent. Because they have a high refractive index of 2.5. So they are transparent. Am I clear?
Yes, sir.
Right. Because of all these properties, diamonds are used for cutting glasses. I'm not talking about the uses of diamond.
So what was the refractive index?
See, it's a you might have done the physics in the chapter of light.
No, I'm asking for diamond. I couldn't note it down.
Okay, it's a 2.5 value refractive index. Cutting glass, drilling rocks, because of its very hard nature. Right? It is used in the ornaments, making the ornaments. Right? Gems, jewelry. and it is used as a tool by eye surgeons to remove cataract. Clear? Because of its very sharp edge, it can be used as a knife to remove the cataract from the eyes. Am I clear?
Yes, sir.
Now I'm talking about the graphite. Carbon as a coal, right? From the coal we can get the graphite. It is treated with the silicon dioxide. We call it silica. At 2273 Kelvin temperature, it forms silicon carbide. Further heating will give you graphite. Right? It is a see chemically both are same. Coal and graphite chemically both are same carbon, but their structure is different. Now I'll discuss about the structure of the graphite. Now I'll discuss about structure of graphite. In the structure of the graphite, each carbon atom is bonded with three other carbon atoms. You can see every carbon atom is bonded with three other carbon atoms and give rise to a sheet-like structure. Right? On every carbon atom, there will be one electron free on every carbon atom because carbon atom has 4 electrons and out of which 3 are involved in bonding. Now there is a second layer, and on every electron carbon atom there are free electrons. They're making bonding like this, right? This bond length is 141.5 picometer and this is equal to 340 picometers. Between two layers, there is a very weak force of attraction. We call it a weak van der Waal force of attraction. Understood? Understood? Yes or no?
Yes, sir.
Yes.
Now, because of such type of weak interaction, it has a low density. It is soft because the two layers that can be like compressed, shift, that can be slided over one another. They are good conductor of electricity because on every carbon atom they have one free electron. They are a good conductor of electricity. Due to these properties, it is used as a lubricant. It is used as a lubricant. Right? Number two, use is it is mixed with the wax and clay for making the lead pencils. It is mixed with the clay and wax to make the lead pencil. The pencil that you're using that contains graphite, the black color of that is due to the graphite graphite only, right? Pencil, right? It is a good conductor of electricity, so it is used for making the electrodes of cells and electrical accessories, right? Any doubt till now?
No, sir.
Now you can make a difference between a graphite and diamond, right? You can write differences between graphite and diamond,
Yes, sir.
right? Another third is the fullerene, Fullerenes, fullerenes. This is another allotrope of the carbon. It has a spheroidal shape. And contain even number of carbon atoms. It contains even number of carbon atoms. How many carbon atoms? 60 to 350. It's a multiple of the C60, so we call it C60 fullerene. It is the most stable form of the fullerene. In which carbon atoms are arranged in the shape of the football. So we call it's a buckyball. It contains 20 6-membered rings and 12 5-membered rings. 26-membered ring and 12 5-membered ring. Right? This type of polymer, this type of allotrope is called the Buckminster fullerene. Buckminster fullerene. Now talk about the physical properties. It's a dark solid. It is C60, means it contains only 60 carbon atoms. This is soft. It is not very hard. Am I clear?
Yes, sir.
I have stopped sharing. Yes, Zo Daniel, can you hear me? Shiloh?
Yes, sir.
Right. Now, in the beginning of the chapter today, I told you that most of the living world is made up of carbon or its compounds. Why so? What is specialty about the carbon that it is forming a very large number of compounds? Right on here, versatile nature of carbon. Versatile nature of carbon. What is the cause of the versatile nature of carbon? Number one, it is a property of catenation. Catenation means the property of self-linking. Self-linking property. Tendency to combine with its own type of elements. Like it can form straight chain carbon atom. It can form branch chain carbon atom. Right? It can form cyclic carbonate compounds. Right? It can form cyclic compounds. So different possibilities are there that it can make bonds. This self-linking property is called as a catenation. This self-linking property is called as a catenation.
Got it, sir.
Now, next, write down tetravalency of carbon. Second reason is tetravalency. Tetravalency means it has a valency of 4. And with that, it can combine with the hydrogen or with the oxygen or with the nitrogen. Right? It has a tetravalency. It can combine with a halogen like chlorine or sulfur, it can combine with any of these elements and form large number of compounds. Okay. Next, tendency to form multiple bonds. When I talk about the multiple bonds, it can make carbon-carbon single bond or double bond or triple bond. All possibilities are there with the carbon or with the nitrogen or with the oxygen. It has tendency to make multiple bonds. Okay, understood?
Yes.
Next, it forms isomerism. It shows the property of isomerism. Isomerism means same molecular formula, but different structural formula. Same molecular formula, but different structural formula. So what happens here? Suppose I say I have a molecule of C4H10. It's a molecular formula of a compound. Then it's one of the possible structure is this one. 1, 2, 3, 4. Other possibility is in the branching. Both of them have the same molecular formula. Both of these contain 4 carbon and 10 hydrogens. But their structure is different. So we call this is a butane and this is a isobutane. Understood?
Yes, sir.
Now I'm now sharing you. Let us do some question based upon this, whatever we have done. The ability to of a carbon to form chain give rise to series of the compound. What do you call it? To a leave it. Newly discovered allotrope of carbon is called as a fullerene. Write down here fullerene. Soft crystalline form of carbon is. You can answer this.
Graphite.
Graphite. Yeah. valency of the carbon in ethylene is, do you know what is ethylene? Do you know what is ethylene?
No, sir.
No. Okay, understand here. This compound, carbon double bond with the carbon and hydrogen, this compound is commonly called as ethylene or ethene. In this case, the carbon is making 4 bonds. 1, 2, 3, 4. So I can say the valency of the carbon is equal to 4.
So is the number of bonds made the
Yes.
valency?
Yeah. Valency means how many bonds an element can make. How many covalent bond element can make. That is called as a valency. Understood? Noted down the structure?
Yes, sir.
Right. So it is equal to now 4. Sorry. 4. Okay. Now the purest form of the carbon is diamond. Right? Okay. Now I'll be discussing some questions, not all, because I have covered a very small topic till now. Carbon is a versatile element. True or false?
True.
Carbon form covalent bond with itself and other elements such as hydrogen, oxygen, sulfur, nitrogen, chlorine. Yes or no?
True.
True. Carbon and its compound are some of our major source of fuels. Yes or no? Diesel, petrol, all these are made up of carbon compounds. So it is also a true statement. Graphite is a good conductor of electricity. Yes or no?
True.
True. After this, we go to 7th question. Diamond is a good conductor of electricity.
False.
False. Graphite is used in pencil.
True.
Okay. Then I have not covered these things yet. Okay. What are fullerene? That you can answer now.
Yes, sir.
So you can write down. Write down. Fullerene is allotrope of the carbon. Allotrope of the carbon, which are spherical in shape and contain even number of carbon atoms from 60 to 350. They are spherical in shape and they contain even number of carbon atoms from 60 to 350.
So from 60 to
350. 350. These questions I have not covered yet, so I will not be discussing anything. Right? This question only we can do. Differentiate between graphite and diamond. You can do or not?
Yes, sir.
Because I had discussed all the details about it. So Okay, now coming back to the main theory again. Next, write down saturated and unsaturated compounds. First of all, I'm discussing here meaning of the word saturated. To understand the word saturated, I'm discussing the structure of ethane, that is C2 and H6. Carbon, single bonded carbon, and rest with the hydrogens. All the four valencies, all the four electrons, valence electrons, are making single covalent bond with hydrogen or with the carbon atom. So we say saturated. Saturated. Complete structural formula. Right? Understood?
So could you repeat why it's saturated?
Yeah. Write down. If carbon makes single covalent bonds with hydrogen or with the carbon, in a compound, then the compound is called saturated compound. Example I have given about the ethane. Draw the structure of the ethane now. I'm stopping sharing for a moment. Yes, Vihan, are you getting this? Vihan, Sheikh?
Yes.
Yes,
Sheikh?
sir.
Okay, everyone, Zo Daniel, Prem,
Yes.
Vedant? Vedant. Okay. Mavish, Shilo?
Yes, sir.
Okay. Mavish, are you also getting this? I'm not getting your response. Okay, fine. All of you are here. So let us now make a complete structure like this. Carbon is having 4 electrons. 1, 2, 3, 4. Another carbon atom has also 4 electrons here. And hydrogen atom has 1 electron each. So what is happening here is this carbon is completing its octet. And hydrogen is completing its duplet. Every carbon atom is completing its duplet here. Understood? Hello? Hello? Can you hear me?
Yes, sir.
Okay. Now, can you make it for this compound, propane? That is C3 and H8.
Transfer.
The one possible structure that you can draw like this, 3 carbon atom, rest all are hydrogen. Got it now?
Yes.
Right. And now you can also draw the Lewis dot structure also. Lewis dot structure. I have here 3 carbon atoms here. And hydrogens here. And you can see that carbon is completing its octet. And hydrogen is completing its duplet here. Am I clear?
Yes, sir.
Right. So all these compounds, carbon is making single bond with a carbon or with a hydrogen. These are called as a saturated. Single bond between carbon atoms is called as a saturated. Done? Done with this?
Yes, sir.
And now I'm talking about the unsaturated. The compounds in which carbon contain one or more double bonds, one or more double or triple bonds between carbon atoms, one or more double bond or triple bonds between carbon atoms. Carbon atoms is called as a unsaturated hydrocarbons. Which contain one or more double or triple covalent bonds between carbon atoms are called unsaturated hydrocarbons.
So what are hydrocarbons?
The compound made up of hydrogen and carbon are called hydrocarbon.
Okay.
Hydrocarbon means the compound made up of hydrogen and carbon is called as a hydrocarbon. So I'm drawing the structure of the ethene. Ethene is also called as the ethylene. Molecular formula is C2H4. right? This is the structure formula of, wait, it is wrong. Carbon here and double bond here. Let us draw the structure here. 1, 2, 3, 4. 1, 2, 3, 4. These are the carbon, and now hydrogen here. Complete octet. Complete octet. You can see. And hydrogen is completing a duplet here.
So how is that an octet?
Octet means 8. Shall I draw again? I'll make it better. Wait. 1, 2, 3, 4. 1, 2, 3, 4. With the hydrogen, it is making bond. Now you can find that a carbon has a complete octet. 1, 2, 3, 4, 5, 6, 7, 8. Can you see that?
Okay.
Same way this side. And hydrogen is completing a duplet here. H2 here. H2 here.
Octet, sir.
Right? So we say there is a carbon, double bond carbon bond is formed. So we say this is a unsaturated hydrocarbon. Unsaturated hydrocarbon. The hydrocarbon in which two or more double or triple bonds are formed between carbon and carbon atoms. Okay.
Yes, sir.
Next we have is ethine. Like carbon, triple bond carbon. This compound is also called as an acetylene. This compound is also called as an acetylene. One, two, three, four. 1, 2, 3, 4. Making bonding with the hydrogen here. Triple bond is formed in between. Carbon octet is complete here. And a carbon octet is complete here. Duplet is complete here.
Sir.
Right? So
Yeah.
it is also an unsaturated hydrocarbon. Am I clear?
Yes, sir.
No. I'll be not discussing the nomenclature. Nomenclature means how to name a organic compound, right? How to name a organic compound. For that we have rules made by IUPAC. This is an international organization of chemistry that has framed certain rules regarding the nomenclature of organic compound. The full form is International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. This is the organization that has that frames certain rules regarding the nomenclature. According to the IPC, the name of any compound has four parts: prefix, next the word root, then we have a primary suffix, and then we have a secondary suffix.
Petals.
Right. First about the word root. This word root depends upon how many carbon atoms are there in the long chain. If I have only one carbon atom, the word root is meth. Two carbon atom, the word root is eth. Three carbon atom, word root is prop. Four carbon atom, word root is but. Five carbon atom, word root is pent. Six carbon atom, word root is hex. Seven carbon atom, word root is hept. C8 is oct. C9 is non, and C10 is dec. Note down this.
Petals. Yes, sir.
Right. And now we talk about the primary suffix. This primary suffix tells about the carbon-carbon single bond, then it is an ANE. Double bond is ENE, and triple bond is YNE. If the compound contains all the single bonds, it is in, double bond in, triple bond ein. Note it down.
Yes, sir.
Now, if I say I have this molecule CH4, then I can say the word root is only one carbon atom, so it is a one, a meth. Single bond in, so it is methane.
Okay, sir. Got it, sir.
Why do we call this compound as a methane? Right? Suppose I say I have this molecular formula C2H6. So I have drawn the structure like this. So I have two carbon atoms here, 1 and 2. It in. It in. Okay.
Yes, sir.
Why it? Because I had two carbon atom. Double bond, single bond between carbon and carbon, so it is a in. Okay. C3H8. 1, 2, 3. You can see all our hydrogen here.
Propane.
Prop in. Similarly, you can put here pentane or hexane, right?
Yes.
If there is a double bond between carbon and carbon, two carbon chain, so it double bond in. Prop in. Got it?
Yes, sir.
This compound. 1, 2, 3, 4. The word root is but. Position of the double bond is at second position. So I'll put here 2 in. If it had been at number 1 position, I would have called it as a butene or but1 in. Understood?
Yes, sir.
If it contains triple bond, then it is an ethine. Ethine. Got it? Now, can you name this compound? Can you name this compound?
Pentane.
1,
Would it be
2,
pentane?
3, 4, 5. Pent 2 ine. Ion bond is there at second position. Got it?
Yes, sir. So can you scroll up?
Sure.
Yes. Done, sir. Thank you.
Now, I have here CH3, CH branching. Select the longest chain 1, 2, 3. This is coming in the branch structure. This will be called the methyl because one carbon atom and sub prefix. So we call it a 2-methyl. 3 carbon chain prop. Single bond in. Prefix, word root, primary suffix. Got it now? Follow
So what
sequence.
would be the prefix be?
Prefix here is the methyl, which is not a part of the chain. This is one carbon atom substituent. We call it methyl. Derived from the methane. Meth means one carbon. So it is a methyl. Word root is prop because I have a 3 carbon chain. In single bond.
So the prefix will be the branched
Yeah,
compound or element.
yeah. Which is not a part of the chain. Understood?
Yes, sir.
Wait. Wait a minute, please. I have stopped sharing for some time. Just a minute, please. Yes. Yes, Vihan. Sheikh. Are all of you getting me? Joe Daniel?
Yes, sir.
Right. Mevesh? Vedant? Okay. Right. I'm now sharing my screen with you. I have this structure. Can you try this molecule? Name the compound. Yes, name the compound.
Is it methyl butane?
Yeah, 1, 2, 3, 4. 2-methyl butane. On the second position,
Bias.
Yeah.
Why do we write 2 before
Yeah.
methyl?
See, first of all, select the longest chain that you have done like this. It's the longest chain. Then you have
Yes.
to do the numbering. Numbering must be done in such a way that the substituent containing carbon atom must get the least count. Must get the least count. I can get here number 2 from the right hand side, and if I start from the right hand side, that will be the 1, 2, 3. That will go wrong. So on the
Okay.
second position, you have a methyl. So we call 2-methyl. Word root is but. Primary suffix is ane. 2-methyl butane. Am I clear?
So if the number was 3, it would have been 3-methyl butane.
Yes, yes.
Okay.
Can you try this?
Then I'm not sure.
No. Go for the longest chain. 1, 2, 3, 4. On the second position and third position, you have methyl. So put here 2, 3 dimethyl. Dime is 2 times. Then we have a word root as a but. Primary suffix is ane. 2, 3 dimethyl butane. Okay.
Yes.
Take up
Can I
this.
copy it down?
Sure, sure. I'm sending you this file also. You will get it. You can note down.
Okay.
You can note down also. Understand now, and I'm sending you the file also, the complete file. Whatever I have written on the board today, it will be with you. It will be sent to you.
No problem.
Understood, everyone? Zoe Daniel?
Yes, sir.
Okay. Now, try this molecule.
So I don't know this.
1, 2, 3. These two are substituent. So 2, 2 dimethyl. Word root is a prop. Primary suffix is ane. See how we have done methyl like that.
Got it. Got it.
Okay. Now, I'll go to next level now. If you have this molecule, means 1, 2, 3 carbon atom joined with each other, CH2, CH2, CH2. This is cyclic compound of the 3 carbon atom, 1, 2, 3. So we call it's a cycloprop. Cyclo is the prefix. Prop 3 carbon chain, single bond in, cyclopropane.
Got it, sir. So for these cyclic compounds, the only thing different will be the prefix,
Yes.
which will always be cyclic.
Yeah. So if I say I have 4 carbon chain, cyclic. Now can you name this compound?
Cyclobutane.
Cyclobutane.
Is it okay?
Cyclobutane. Got it? Okay.
Yes.
Now 1, 2, 3, 4, 5. Now name this compound.
Cyclopropane.
Cyclopentane. 5 carbon chain.
Okay.
Cyclopentane. And last molecule I'm not telling you. It is not a cyclic compound. We call this compound, remember it, for the time you remember it, benzene. It is benzene. We can represent the molecule with this alternate double bonds, or we can represent the molecule like this. All are basically same thing, we call it benzene. Remember it.
Yeah.
Okay, any doubt till now? Vihan?
No doubt, sir.
No doubt. Sheikh?
No doubt, sir.
Okay, fine. So this much you prepare, because we have done only beginning part of this chapter yet, just a beginning part. It will take 2 classes more to complete the chapter, right? So we'll be doing the assignments also step by step. By this time, by the next class, you just prepare all this much, right? Okay, now I'm ending session now. See you in the next class.
Okay.
2 घंटे का कक्षा हो गया.